So in this video, we are going to solve the problem of max number of k-sum pairs. Let us open that problem. First, we'll go through the problem statement. You are given an integer array. The name of the array is nums and an integer k. In one operation, you can pick two numbers from the array whose sum equals k and remove them from the array. Return the maximum number of operations you can perform on the array. Example, this is a nums array having elements 1, 2, 3 and 4, wherein the value for k is 5. Now we want to identify two numbers such that their addition equals k. If yes, then remove those two numbers from the array. Starting with nums, remove numbers 1 and 4. If we remove number 1 and remove number 4, their addition equals 5 and k is 5. After removing 1 and 4, the array becomes 2, 3. The addition of 2, 3 also becomes 5. Hence, we are going to remove 2, 3 as well. And at last, the nums array becomes empty and the number of operations that we have performed is 2. So, there are no more pairs that sum up to 5, hence a total of 2 operations. Let us look at the second example. Here, the nums array is 3, 1, 3, 4, 3. The value for k is 6. If you look at the array, the addition of first element and last element equals 6. Hence, these two elements will be removed from the array, leaving the nums array equal to 1, 4, 3. Now, if we perform the addition of 1 plus 4, it becomes 5. If we do 4 plus 3, it becomes 7. Hence, now you cannot perform any more operations such that the sum of the array elements becomes equal to 6. Since there are no more pairs that sum up to 6, hence a total of 1 operation. Now let us run this code via AI. So we will be using AI to guide us to the solution and not give us the direct answer. Let me copy the question. So I have copied the question. Coming to Claude. Well, so my approach would be to use two pointers left and right. Left will start from 0 and right will start from array length minus 1. Then we will add array of left with array of right. If the addition equals k, then increment operation by 1 and remove array of left and array of right from the array. However, in this case, if we move from left to right, then what if after removing the element, they will switch to which index? Also, what will be the terminating condition? Can this be achieved using a single loop, that is in big O of and time. Let's get started. Okay, let's go. 2 pointers is a solid instant here. Before we dive into implementation, I want to make sure the foundation is solid. You mentioned removing elements from the array when a pair is found. That's one mental model, but think carefully. Does the two-pointer approach actually require you to physically remove elements? What condition would tell you I am done, no more pairs to check? What condition will tell you I am done, no more pairs to check? That condition would be when left. Okay, we will start. The loop condition will be left less than right. When left becomes greater than right, then that would say no more pairs to check. I don't think this will be doing the solution will be this simple. Exactly right on the terminating condition. Now here's my next question. You mentioned removing elements when a pair is formed, but if you are using left less than right as your condition and you're moving pointers inward, do you actually need to remove anything from the array at all? What could you do to the pointers instead of removing elements? The pointers will be moved inwards. No need to remove the elements. So now you have found now you have the found case handled. Both pointers move inward and you implement operations. But here's the critical question. What if nums of left plus nums of right not equal to k? What do you do with the pointers then? Okay, think about this carefully. There are two sub cases here. But here's the critical question. What if nums of left plus nums of right is not equal to k? So in this case, we will fix left at its current position and move right until we find nums of left plus nums of right equal to k. Similarly, you will do this by fixing right. Okay, so this is one case. This is one case. Okay, but think about this. If you are just blindly moving right inward, you might miss valid pairs. Here's a hint. The two-pointer approach works cleanly only on a sorted array. Okay, the hint is the two-pointer approach works cleanly only on a sorted array. If the array is sorted and nums of left plus nums of right is greater than k, which pointer should move and why? And what if the sum is less than k? Okay, so if it is a sorted array, that means let us say we have array 1, 2, 3, 4, 5 and the value for k is 5. Then in that case, nums, let us say left is 0 and right is the end of the array. So nums of 0 is 1 and nums of right, which is 5. So 1 plus 5 is 6. Now 6 is greater than 5. Now in this case, which pointer should move and why? Okay. If it is greater, then the right pointer should move inward. If the sum is greater, then right pointer should move inward, else left point. Okay, exactly, that's the core inside. Now before we go, let me ask you the prerequisite question. Does the input array come pre-sorted or do you need to sort it yourself first? And if you need to sort it, what does that do to your overall time complexity? So let us take a look at the example. 3 1 3 3 1 2 3 4. No. The question says the nums array is not sorted. The nums array is not sorted. Does the input array come pre-sorted or do you need to sort it yourself first? We need to sort it ourselves. And if you need to sort it, what does that do to your overall time complexity? Depending on the sorting method, the time complexity will change, and that will be our final time complexity, because moving two pointers is big O of cal, whereas sorting depending on the method, let us say in case of I think binaries bubble sort, it is big O of log n. But pause on the complexity line. What is the actual time complexity of bubble sort? It's not big O of log n. Take a moment and reconsider. I don't recall it. I don't recall exactly. Okay, bubble sort is big O of n square. So the question is, what sorting algorithm would give you the best time complexity here, and what would that make your overall time complexity when combined with the two pointer pass? What sorting algorithm I should use? Binary sort. Binary sort says it will give big O of log n. My bad. There's no sorting algorithm called binary sort. You might be thinking of binary search, which is a search technique, not a sorting algorithm. Think about the most commonly used efficient sorting algorithm that gives big O of n log n time complexity. It's probably the one you'd reach for in any language. You just built it. So what is it? Quicksort? Quicksort. Yes. Quicksort is one of them and merge sort is another. Most languages as built-in part functions use one of these under the hood and give you big O of n log n. So putting it all together, if sorting is big O of n log n and the two pointer pass is big O of n, what is the overall time complexity of our solution? It is big O of n log n overall time complexity. Before we code, what is the space complexity of your approach? Think about what extra space are you using. Space complexity will be big O of 1, since you will be using count to store operations. You're sorting the array. Does sorting always happen in place or does it? Right. Think about merge sort versus quick sort. It will be big O of it. It depends. That's the nuanced answer. Quicksort sorts in place. Big O of login space. Call stat merge sort requires extra array. Okay, in most introduce when you use a built-in sort, you would say big O of login space for the call stat. But it's worth mentioning this dependency. Okay, now one last thing before coding. What edge cases should your solution handle? Edge cases include empty array, a already sorted array. Already sorted array is actually not really an edge case where algorithm handles it naturally. Think about more tricky input scenarios specific to this problem. For example, what if no pairs sum to k at all? Or what about duplicate numbers? Does your two-pointer approach handle those correctly? Right. If no pairs sum to k at all, then count will be 0. If there are duplicate numbers, the two-pointer approach will handle it. Correctly. What if k is odd and all numbers are the same? Does your approach handle that? What if k is odd and all numbers are the same? You are contradicting. You said k is odd, but k is even. That is k is equal to 6. Yes, the two-pointer approach will handle this case as well. So to confirm your answer with nums equal to 3, 3, 3 and k equal to 6, walk me through what your two pointers would do step by step. How many operations would you get? So we will start with left equal to 0 and right equal to num start length minus 1, which equals 3. So here we will check nums of left plus nums of right is not equal to k. If it is true, then we will check nums of left is greater than nums of right. If yes, nums of left plus nums of right is greater than k. If yes, then move right minus minus, else move left plus plus. So when nums of left, then in the else part for nums of left plus nums of right, for nums of left plus nums of right, increment count plus plus. So with this, for the above array k is 6, we start with left equal to 0, and right equal to 3. Then our if condition evaluates. If condition, it returns false because nums of left is not equal to nums of right. Then its else block is executed, which says count plus plus. So when left is 0 and right is 3, count becomes wolf. Okay, now after this, inside the else part, you will also increment left plus plus and do right minus minus. So now left is 1 and right is 2. So here also the same if condition will evaluate. False, count will be 2 and then left will become 2 and right will become 1. So here left becomes greater than right. The loop terminates and the returned answer is 2, which is correct. How you should communicate in an interview. Now I have one small but important question before you code. What will you do to the array before starting the two pointer loop? Don't forget the prerequisite step we discussed. I need to sort the array first. We'll sort the array first. Go ahead and code it up. Okay, let me code that up. Going to LeetCode. So a final approach would be sort the array, use two pointer method to traverse from left to right. Use two pointer method to traverse from left to right. Terminating condition would be left greater than right. Then if nums of left plus nums of right is not equal to k, then check if their addition is greater than k, then do right minus minus, else do right, else do left plus plus, else do right minus minus and left plus this. Maintain a count variable that will sum up all the operations that we have done so far. Can at last return the count which represents the number of operations. In step 4, we wrote the else condition is right. Give count there. Make sure that's okay. You got it. Good catch. So here we are in the core max operations. Let me first check for array sort method. So here it is array dot sort dub. So dot sort, just pass in the array, it will be sorted. What is to sorted? The to sorted method of array instance is the copy version of the sort method. It returns a new array with the elements sorted in ascending order. It returns a new array. And what does sort do? It sorts the elements of array in place. We need sort. We cannot use sorted to sorted because it will return a new array. And this will do sorting in place. See, going back to LeetCode, here we are going to do receive const nums is equal to nums dot sort. So we have sorted the array. After sorting the array, the next operation is to pointer method to traverse from left to right. So let left is equal to 0. Let right is equal to nums dot length -1, and let operations is equal to C. A terminating condition is while left is less than right. Inside this, check the addition of nums of left with nums of right is equal to K. When the addition of is not equal to K, so we'll do if nums of left plus nums of right is not equal to K. In that case, we check. So let me use a variable let addition, because this will perform the addition only once. Whereas if we go on using nums of left plus nums of right everywhere, that would add to CPU computation. So if addition is not equal to K, then we check if addition is greater than K, then we lose the right pointer even. So right minus else if addition is that else addition is less than K, in that case we move the left on the reward. So that becomes left plus plus. After doing this, coming to the else part of this one, if addition not equal to K, it means addition is equal to K, then we increment the count, we move the left pointer inward, also we move the right pointer in. And at last, when this loop terminates, we return operations. So above we have variable operations, not count. Now let us give this code to Claude, asking it to verify our implementation. Here is the code. Okay, wait. So, in order to do sorting for JavaScript numbers, we have to pass a compare function. For comparing numbers, you have to pass in this function, a minus e. So, example would be numeric string array, number array dot sort. So, it gives 1 to 104. Then we call compare numbers. Got it. So, instead, I think compare numbers can also be passed as a callback function. So, number array dot sort think this can be done this way, dot sort, which takes a callback function a minus b, a comma b, and then return a minus b. Now let us feed this to Claude as the updated code. There's a stray semicolon inside the package spot here. Fix it. Okay, bad. Okay, so that's still incorrect now. We'll come back to the final review later on. For now, let us run this code. Run. Yes, the code is working as expected. Let me submit this. Preparing runtime environment. So the runtime, it took 140 milliseconds. Why? It took quite a lot of time. Okay, so this is our code. It has taken quite a lot of time. But all the test cases passed. We'll come to that later. However, if we look at say 50 millisecond of runtime, let us click on this. How this code is written. Okay. So they have made use of new map operations or counts num of nums complement is equal to k minus now. If count dot has complement and counts dot get complement greater than 0, increment the operations, then counts dot set, else counts dot set. Return operations. Okay, so this and the earlier you would say code which we had implemented, and above that it is the optimized op. Okay, now coming back to Claude. So here also let us click on analysis part. It will analyze our code. So here it says 2 pointers of sorting suggested hash table slash 2 pointers. Suggested 2 pointers of sorting suggested is hash table 2 pointers. So we have not used hash tables. Key idea: maximizing pair removals using sorting with 2 pointers on hash map frequency counting. Okay, could you swap the sort for a hash map to slash the time complexity down to linear? Okay, so I'll have to look into this. I think we have already looked at that code part, the optimized one. Then efficiency is, okay, current is big O of n log n, but the suggested is big O of n. Switch to a hash map approach to achieve linear time complexity by trading space for speed. Okay, so this is our code. Readability structure. So our code is not the optimized one. It does give the correct answer, but it is not the optimized one. For the optimized one, we should use hash map, which I will do it in the next video. Now coming back to Claude, let us go through the review part. Correctness, logic is solid, 2 pointer approach is correctly implemented, both examples work pass. Complexity, big O of n log n, time complexity and space complexity is big O of log n, which is correct. Readability, code is clean and easy to follow. Nums equal to nums dot sort, the reassignment is unnecessary. Okay, dot sort notates the original array in place. Okay, got it. The comment when the addition of not equal to k is redundant is already self-explanatory. Comment should add why not repeat what. You communicated, interview communication. You communicated your approach well before coding. The step-by-step walkthrough of the 333 example was excellent. Exactly what interviewers want to see. Score 7.5 out of 10. One concrete improvement for next time. Always test your code mentally with at least 2 examples. One normal, one edge case before declaring it done. Now let's do the 5-minute post-mortem. Add to that. Okay, let's do it. What clues did you miss? The problem says pick 2 numbers for whose sum equals k and remove them. The word remove is a clue that order doesn't matter. Okay, which hints that sorting is safe and won't affect correctness. Got it. What pattern should you have recognized immediately? Two numbers that sum to a target is a classic pattern. You should have instantly thought two pointers on sorted array or hash map frequency count. Whenever you see pair that sums to k, your brain should fire the pattern recognition within 30 seconds. Okay. The pattern is two pointers on sorted array or hash map frequency count. What would an interviewer think? You knew two pointers intuitively. You communicated before coding. You confused bubble sort complexity and introduced binary sort. Sorting complexities must be memorized cold. The JavaScript default sort bug. This is a known JavaScript gotcha that interviewers specifically watch for. What would you do differently next time? Before coding, always ask yourself, does JavaScript sort needs a comparator here? Memorize this code. Big O of n log n for quick or voice sort. Big O of n squared for bubble or selection sort. When you see pair summing to k, immediately name the pattern out loud for the interviewer. Two numbers that sum to a target. Overall, a solid session. The thinking was good. The execution was clean. Keep going. Thank you. Can you help me understand the hash map frequency? Okay, this was about max number of k sum pairs using two pointers and to solve it well. If you want to explore the hash map approach, I'd suggest we treat it as a fresh problem session. Well, where I'll ask you guiding questions and you discover the approach yourself, just like we did today. We start the new session for it tomorrow. So if you have learned something valuable today, please do like, share and subscribe. Thank you.